Hello and welcome. In this video, we're going to learn about REST API, authentication, and authorization. Authentication is the process of verifying the digital identity of a client or a user before granting access to an API. Authorization is the process of determining what resources a client or a user can access. For a client or a user to have access to an API, they must register by making a POST request to a register endpoint, passing the personal details on the body like name, email, and password. Usually the email is the username used for the credentials. The API then sends this data to the server to store in a database. The password must be hashed before stored on the database to prevent an attacker to determine the original password. Password hashing is a one-way process of securing plain text password by creating a bit string of a fixed size called hash using cryptographic hash function. So a simple password becomes a huge string. Once the registration process is done, the API should send a success response to the client, informing that the new user is created. Then to access the API, the client must authenticate by making usually a POST request to a login endpoint, passing the credentials entered on the registration request. If the credentials are valid, then the API should return a success response with an access token on the body response, which is a JSON Web Token. JSON Web Token is an open standard that defines a compact and self-contained way for securely transmitting information between parties as a JSON object. This information can be verified and trusted because it's digitally signed. When the API server creates the JSON Web Token, it signs with the secret key that only the server knows. That signed token must contain information about the user, like the unique ID, but also can include other details like name and email, for example. It also contains the IAT, which stands for issued at, and it's the time the token was issued. Then the EXP, which stands for expiration time, and is the time after which the token expires. And also the sub, which stands for subject, and is a string that identifies the principal that is the subject of the token. The subject can be the service the token will be used for, a user detail, or an organization. This access token should not be stored on the API server, but it should be stored securely on the client side. So when the client makes a request to an API endpoint, it should pass the access token along with the request. The API then will verify if the access token is valid, and if it is, it will send a success response with the resource data the client requested. If the client doesn't pass the access token along the request, or if the token is invalid or expired, the API should send a response with the 401 unauthorized status code, which is the correct status code for this situation. The 401 unauthorized status code indicates that the client request has not been completed because it lacks valid authentication credentials for the request resource. And let's say the client is not an admin user, and if it tries to access an endpoint only administrators can access, passing the access token on the request, the API verifies that the access token is valid. But since the user is not an admin, the API should send a response with the 403 forbidden status code, which is the correct status code for this situation. The 403 forbidden status code indicates that the server understands the request but refuses to authorize it. This status is similar to the 401, but re-authenticating makes no difference. The access is tied to the application logic, such as insufficient rights to a resource. Now, when the client is using the API by making several requests using the access token, an attacker can break into the client's network traffic and steal that access token. So when the server API creates that access token, the expiration time configured should be short, preferably less than 1 hour. So when the attacker is making requests to the API using that stolen access token, soon it will expire and the attacker won't be able to use it anymore. The only way for the attacker to use the API is logging in, but the attacker doesn't know the client credentials. Since the access token expiration time is short, when the client is making several requests to the API, soon that access token will be expired, and the client needs to log in again, passing the credentials to receive a new access token. The problem is that the client will have to keep re-authenticating every time the access token expired, leading to an exhausting task. To prevent that issue, when the client authenticates by making a request to the login endpoint, the API, in addition to the access token, it should send another token called refresh token. The refresh token is a special JSON Web Token that is used to obtain more access tokens. This allows the client to have a short-lived access token without having to collect credentials every time it expires. When the API server creates the refresh token, it signs with the secret key, different from the access token, that again only the server knows. And inside the refresh token should contain only a unique ID to identify the user, the issue ad, the subject, but the expiration time should be longer than the access token. Depending on the application, should be days, weeks, or even months till expired. Different from the access token, the refresh token typically is stored on the server side, and also securely stored on the client as well, along with the access token. So when the client makes a request to an API endpoint, it should pass only the access token along with the request and not the refresh token. When the access token is expired, the API should send a response to the client with the 401 unauthorized status code and also some sort of code on the response body informing that the access token is expired. So the client will intercept every response from the API and check if the status code is 401 and if the access token is expired. If so, the client will make a post request to the API, sending the refresh token on the request body. The API will verify if the refresh token is valid, and if it is, it will send a success response to the client with the new access and refresh tokens. So the client can continue with the request sending the new access token. Everything is done automatically on the background. The user won't even notice. Now, the traditional way of authenticating the client by making a request to a login endpoint, sending the username and password credentials might not be enough. For a complete security API, it might need a second step before authenticating the client to the API. This method is called two-factor authentication. Two-factor authentication is a security system that requires two separate, distinct forms of identification in order to access the API. So the first step is to make a request to the login endpoint sending the credentials. When the API sends these credentials to the server will generate a PIN code and send this PIN code to the user by email or SMS. And then it will send a response back to the client with a temporary token, and this token is usually stored for a short period of time on the server's cache. Then for the second step, the client should make another request to a different endpoint, sending on the request body the temporary token sent on the response and the PIN code sent on the email or SMS. If everything is okay, the API should then authenticate the user and send a success response with the access and refresh tokens on the response body. Although this is a safe way to implement two-factor authentication, there is a better way, which is using an authenticator app to generate the PIN code. An authenticator app is an application that usually gets installed on a smartphone or mobile device. The app generates a 6 to 8 digit securely key in a specific time window, usually 30 seconds. So the app will generate a PIN code, and every 30 seconds it will generate a new one. Some examples of authenticator app is the Google Authenticator, Microsoft Authenticator, and Twilio Authy. So by using an authenticator app, the client still have to make a request to a login endpoint, sending the credentials on the request body. When the API sends these credentials to the server will send a response to the client with the temporary token stored on the server's cache. And in parallel, the authenticator app is generating PIN security codes every 30 seconds. Then for the second step, the client should make another request to a different endpoint, sending on the request body the temporary token sent on the response and the PIN code generated by the authenticator app every 30 seconds. If everything is okay, the API should then authenticate the user and send a success response with the access and refresh tokens on the request body. To configure the authenticator app, the API server should generate a QR code signed with a secret key that only the server knows. And the authenticator app should read this QR code. If everything matches, the authenticator app is configured and ready to use. The client can log out from the API by making a request to a logout endpoint, passing the access token within the request. The API will inform the server, which will delete the refresh token related to the user and also save the access token sent on the request on a blacklist, and then send a success response to the client, usually with the code 204, which means no content, because there is nothing to send on the response body. So when the client tries to access an endpoint passing the access token, Since the client had already logged out, that access token is saved on a blacklist on the server, making it invalid. So the API will return a 401 unauthorized status code to the client. REST API authentication and authorization is an essential part of any API system, as it provides a secure way to control access to the API and its resources. Understanding the workings of authentication in REST APIs and the different types of authentication methods available will ensure that the API is secure and that only authorized users and applications can access its resources. Let's see in practice how REST API authentication and authorization works by building an application with Node.js and Express. I'll be using VS Code for the tutorial, but feel free to use the code editor you like. I have an empty folder open here on VS Code called REST API auth Node.js. Let's start by creating our Node application by opening the terminal on the top and type npm init. And we can use the -y flag here to populate all options with the default values. Okay, project created, and we have a new package.json file with all the project's details here. Let's go back to the terminal so we can install the dependencies we'll be using. Let me clear here. So npm install, and we'll use Express to organize our routes. And we're not going to use a database on this tutorial, but we'll install a dependency to simulate a database, so we will store the data on separate files. There's a few dependencies out there that does the job, like LowDB, JSON NodeDB, Locky.js, but we'll be using one called NEDB, which is very easy to use and it doesn't require any extra configurations. But NEDB does not support promises, so we can use async and await. So instead, we'll install a module called NEDB-promises, which is the same as the original module, but this one supports promises. And we'll install JSON Web Token to generate and verify the tokens we'll use to authenticate the user to our API. Now, we need a dependency to hash the user password before saving on the database once the user registers to our API. So we'll be using bcrypt.js. So for this part, that's all the dependencies we're going to use, but we'll install more dependencies during the video for the two-factor authentication part. And great, dependencies installed, and let me close the package.json file and reopen. And you can see here the dependencies we just installed inside the dependencies object. Still inside the package.json file, there's a property called main pointing to an index.js file, which is going to be our main file. So let's create this file here on the root, new file, index.js. Now inside this file, I'm just going to paste some lines of code here because in every video here on the channel, I just keep repeating myself setting up a basic Express server. So on the top, we're importing Express module, then we are initializing Express into a constant called app. Then we are configuring Express to parse JSON data from the client request body. Next, we're just creating a basic route, like a home route, sending a simple response to the client with the message REST API, authentication and authorization. And last, we're telling Express to listen on port 3000 and print a message on the console. Very simple. Now let's run all this just to make sure everything is working. So back on the terminal, let me clear here and run node index.js or just index and hit enter. And great, server started on port 3000. Now I'll be using Postman to test the API requests, but feel free to use the tool you prefer to make HTTP requests. Now inside Postman, I'll open a new request here on the top, and the method of this new request we can leave as get, and the URL will be localhost port 3000, which is the home route. And we can click on send, and here it is. We got a status code of 200 OK and the message REST API authentication and authorization on the response body. So our server is working. Back on VS Code, so every time we change something in our project, we have to save, stop the server, and run again node index command. I'll be using a module called nodemon, which will monitor our project every time we save a file. It will start the server automatically for us. So let me stop the server here on the terminal and let me clear and type npm install nodemon. And this is going to be a developer dependency, so I'll add a flag here, --save -dev, and hit enter. Okay, nodemon is installed, and if we check here inside the package.json file, you can see under the dev dependencies, nodemon module is installed. That means that when we publish this project to a production server, only the dependencies will be installed and not the dev dependencies. These are only used during development. Now, to run nodemon, there's a property here called script. And let me get rid of this test script here because we're not going to use it. And let's add a new one called start. And instead of running the node index command, we'll now run just nodemon. Now, back on the terminal, let's run this new command here by typing npm and the start command we just added. Hit enter. And now nodemon will monitor our application and restart the server whenever we save a file. As you can see, we got the server started on port 3000 message. We can even close the terminal for now. Okay, back on the index.js file, let's create a new route here below the home route. And this route is for the users to register to our API. So the client needs to send the user information like name, email, and password, so we later can authenticate the user. For this project, we're just going to create everything inside the index.js file, but of course in a real project, you definitely want to organize and separate the files into different folders. So app, dot, and this is going to be a post request, and the name of this route will be /API, /auth, /register. And of course, you can add the name you prefer to this route as long as it makes sense with the context. And this is going to be asynchronous route, so async, the request and response parameters, arrow function. And inside every route in our project, we're going to add the try block and the catch block with an error object as a parameter. And if any error happens inside the route, we can catch inside here. In this case, we can return a response to the client. So return response.status, and we're going to return the 500 status code, which means internal server error, and a JSON response with an object inside and a message, which is equals to the error object here from the catch parameter dot message. Now inside the try block, the client will send some data from the user. So first we need to grab these details from the request body. So I'll add a new const here and an empty object equals to the request.body. So from the request body, we'll expect the name of the user, the email, and the password. We could add more fields, but for this tutorial, that's all we need. Now we need to check if these fields are being sent on the request body. So instead of checking for each required fields, I'll just add one if statement for all fields. So if, and inside we're going to check if the name is not present, and I'll add an exclamation sign here on the beginning. So if the name is not on the request body, or if the email or the password. So if one of these fields are not on the request body, then we're going to return a response to the client. So return response.status, and here we're going to use the 422, which means unprocessable entity, and usually we use this code when the client is sending invalid information to the server. Then a JSON response, and inside the object with a message saying something like, please fill in all fields, and I'm gonna put here name, email, and password. Okay, of course in a real application you should add a better validation here, especially in the password field, checking if it's a strong password, by checking if there is at least one lower and one uppercase letter, numbers, symbols, and a minimal length. But for our example, this is fine. Now, if all fields are available, we need to save the user details on the database. So let's use the NEDB module we installed for this. So let's import the NB module here on the top, below the express import. So const data store in uppercase, because this is a class, but you can give any name you like. Equals to require nedb-promises. Okay, and below the express.json configuration, let's create a constant that will simulate a user table or collection. So const users equals to data store that we imported on the top, dot create, and we'll store all DB files simulating the database inside the root. So users, and I like to create these files with an uppercase, but this is just a personal choice, .db. This also could be a .json if you prefer. Okay, so our users constant simulating a users table is configured. Great, so before saving the new user on the database, we need to hash the password so it's securely stored on the database using the bcrypt.js module. So let's import the bcrypt.js module here on the top. So below the nedb promises import, const bcrypt equals to require bcrypt.js. Okay, now back on the route. I'll create a new const here called hashed password equals to await, because this will return a promise and we need to wait for the result before proceeding. The bcrypt module dot hash function, and inside we need to pass two parameters. The first parameter is the password the client is sending here, and the second parameter is something we call salt to create a unique hash, and we can use 10 here. Okay, so now that we have the hash password, let's insert on the database. So I'll create a new const called new user equals to await the user's constant dot insert method, and inside an object with the details we want to store on the users table. So we'll add the name property here equals to the name. We got it here from the request body, and since the property name is the same as the value, so we can leave just the name here. Great. Now same for the email and the password. So here we don't want to store the original password from the request body. Instead, we'll store the hashed password we created. So hashed password. Along the video, we'll be adding more fields here, but for now, this is perfect. And now we need to send a response to the client informing that the new user is created. So return response.status, and here we can use the 201, which means created, .json, and inside an object with the message saying something like user registered successfully. Awesome, let's test this new register route on Postman to see the result. So here on Postman, I'll open a new request, and this is a post request, and the URL is localhost 3000 /API/auth/register. Now we need to send a JSON body on the request, so I'll select the body tab here and select the raw option. Then on the drop down here on the right, we can leave as JSON. Now here on the body, let's create an object with the name inside double quotes, and I'll add John Doe, for example, and the email field, and I'll just add a random email here like jd@domain.com. And last is the password, and I'll just add a simple password here like 123456. Okay, we can click on send, and perfect, we got the 201 created status code and the user registered successfully message on the response body. Now back on VS Code, we have a new file called users.db, and inside the new user the client registered with the name, email, and as you can see the password, which is 123456, but it became this weird string here because it's hashed. And NEDB created automatically this underscore ID field here, which is simulating a primary key for the user. So what we can do is return to the client, in addition to the message here, the underscore ID field as well. So let me format here a little. and I'll add a comma. The ID equals to new user, we just inserted here, dot underscore ID. Awesome, so our new register route is working, but we just need to add one more validation here, because if we try to add another user here on Postman with the same email, for example, so I'll just click on send. We got the 201 created status and the success message, along with the new user ID. And if we check on the users DB file, we have two users with the same email, and that's a really bad practice. So we must make sure that we don't allow to create a new user with an email that already exists. So back on the index.js file, inside the register route, before we hash the password, let's add an if statement. And inside the await users dot, and we can use the find one method. And inside an object with the fields we want to search. So I'll add the email field, and if it's equals to the email, send on the request body. But since the key and the value has the same name, we can leave just email here. And if it finds a user with the same email, that means the email is already being used. So let's return a response to the client. Return response dot status, and the code we can use the 409, which means conflict. And a JSON response, the object, and inside a message saying something like email already exists, for example. Now let me delete the users DB file here so we can test from scratch. And back on Postman, I'll leave the request body with the same details from before, and let's click on send. Great, we got the 201 created status code, the message, and the user ID on the response body. Now if we click on the send again, sending the same email, we got the 409 conflict status code, and the message email already exists on the response. So our validation checking if there is a user with the same email is working. Let's try some other validations here. So for example, I'll remove the name property here and click on send. And great, we got the 422 unprocessable entity status code and the message saying please fill in all fields, name, email, and password. So the validations are working perfectly. Let me add the name property back, and let's try to add a new user just to make sure everything is working. So on the name, I'll add my name here. The email, I'll change the initials here to BM, and the password I'll leave as the same. Let's click on send, and perfect. We got the 201 created status code, the success message, and the new user ID on the response. And let's just make sure everything is working by opening the users.db file. And great, we have two users here on our DB file. And if we check the passwords, both these users have the same password, but as you can see, they look completely different because it's hashed. And great, so our register endpoint is completed for now. And let's save this request by clicking on save. And on the request name, let's put register. And on the collection name, we can put REST API, authentication, and authorization. Okay, click on save, and perfect. Let me close here. And we don't need to save the home route, so I'll just close. Now back on VS Code, let's create the login route, and later we'll create other routes that's gonna require the user to be authenticated so it can access. Let me just collapse here and hide the explorer. So below the register route, let's call the app constant dot post, and the name of this route will be /API/auth/login. The async word, the request and response parameters, arrow function, the try block, and the catch block with the error object inside. And inside the catch block, we can copy the same code from the catch of the register route and paste inside here. Okay, let me just collapse here. Okay. Now inside the try block, this route expects that the client sends the credentials of the user. That means the email and password. So I'll create a new const here. and an object equals to the request.body, and we're going to extract the email and the password. Now we need to validate if these fields are not null or empty, so I'll add an if statement and check if the email or the password are not on the request body. Then let's return a message to the client, so return response.status, and the code will be 422 unprocessable entity, and a JSON response with a message saying something like, please fill in all fields, email and password. And of course in production you might want to add a better validation here, but this is fine for our example. Now we need to get the user details from the database by the email. So I'll create a new const called user, which is equals to await the user's constant, simulating the user's table, dot find one, and inside the object, the email. Now we need to check if the user was found on our database, so I'll add an if statement, the exclamation user. If the user doesn't exist, then we need to return response.status. And the status code here, we could use the 404, which means not found, but instead we should send the 401, which means unauthorized. Because if an attacker is trying to access the API, we shouldn't give any clues like the email doesn't exist or if the password is incorrect. This way the attacker might not know if the email it's trying to access exists or not on the database. And let's send a JSON response with a message saying email or password is invalid. So if the email or the password is wrong, we should send the same response. Now we need to check if the password the client is sending matches with the hash password we stored on the database. So I'll create a new const here, call password match equals to await, and I'll call the bcrypt module dot and the compare function. And this function expects two parameters. The first one is the original password, that means the password the client is sending. So I'll put password here. And the second parameter is the hash password from the database. So we can call the user constant dot password. Now the compare function returns a promise, and once we have the result, as you can see here, it returns a Boolean value. So if this password matches, it will return true, otherwise false. So I'll add an if statement here, the exclamation sign, password match. So if it's false, that means the password the client is sending doesn't match the user password stored on the database. So let's return the same response from up here. Let me copy and paste, returning 401 and the message email or password is invalid. Now, if all validations are okay, the email exists and the password matches, we should generate the JSON Web Token and return on the response body to the client. So for this, we need to import on the top the JSON Web Token module. So let's import below the bcrypt.js import. So const jwt equals to require JSON Web Token. Okay, now back on the login route, I'll create a new const called access token equals to the JWT JSON Web Token module dot the sign function, and this function expects three parameters. The first parameter is called payload, which can be a string or an object with the data we want to store inside this token. We could start a user ID, username, and email, but let's just add the user ID, which is the primary key of the user's table. So user ID equals to the user constant, we add it up here, dot the underscore ID, which NADB generated for us. Like I said, we could add other user details here, but all we need is the ID. And make sure to never add sensitive information here, like the password, for example. And the second parameter is a secret key that we're going to use to verify if this token is valid. This secret key only the server should know. This is like a password, so it should be strong, containing numbers, symbols, lower and uppercase letters. And since we're gonna use this secret key in other functions, so I'll start this in a different file. I'll create this file here on the root, so new file, and I'll call this config.js. And inside this file, we're gonna store all constants, configurations we'll use along the project. And we need to export all these constants. So module.export equals to an object, and inside the access token secret. And for this example, I'll just add a simple secret here, something like my access token secret. Now back on the index.js file, let's import here on the top the config file we just created. So const config equals to require /config. Back on the login route, inside the JWT sign function, on the second parameter, let's call the config file the access token secret. Great. Now the last parameter, we can specify some options here inside an object. So we can add the subject of this token, which can be a user detail, an organization name, the purpose of this token. So this will depend on the context. So for our example, I'll add here access API, because this access token purpose is to access our API. The subject is not required. We could omit this information if we want, but it's a good practice to add the subject. And we can also add the expires in property, which is for how long this token will be valid. So let's say we want this token to be valid for 1 day. We can type here 1D, for example. Or if we want this token to expire in 1 hour, we can add 1H. So we can add the number followed by the unit initial, okay? Let's just leave 1 hour for our example. Okay, now if we don't pass the expires in property, the access token will never expire, and that will depend on your API requirements, but it's definitely a good security practice to add the expiration time for the access token. And that's it. All we need to do now is return a response to the client with this access token, and we can add some details from the user as well, like the ID, name, email, because if the client is a browser or a mobile app, it might want to show the username or email on the top of a menu bar or a sidebar, for example. So return response.status, and we're gonna use the 200 OK status code .json, and inside the object we can send the user ID, for example. So ID equals to user._ID, and the name equals to the user.name, the email equals to user.email, and of course the access token equals to the access token we just created. And since the property name is the same as the value name, so we can leave just access token here. Great, let's test this new route on Postman. So I'll open a new request tab here, and this is going to be a post request, and the URL is localhost 3000/API/auth/login. Open the body tab, select the raw option, the JSON type, and on the request body, inside the object, the email equals to, let's check the emails here inside the users DB file. Okay, let me copy one here and paste inside the email property. And the password, we added as 123456 for both users. Okay, we can click on send, and perfect, we got the 200 status okay, and the user details on the body along with the access token. Now let me copy this access token here, and I'll open the browser, and if we visit the jwt.io website, okay, and if we scroll down a little, we can paste this access token here, And on the right side, we can see some details for this token, like the header. So it's using the standard algorithm here, which is HS256, and the type is JWT. And down here, we can see the payload details of this token. So we added the user ID and the IAT, which is the time this token was issued, the EXP, which is the expiration time of this token, and last is the sub, which is the subject. In our case, we added the access API. So our token was generated and signed successfully. Now back on Postman, let's just make sure our validations are working. So for example, I'll type a wrong email here. I'll just add test and click on send. And great, we got the 401 unauthorized status code and the message email or password is invalid. Now let me put back the correct email and type a wrong password. So I'll add a 7 here on the end. Click on send and we got the exact same response. So we shouldn't give any clues saying something like the email doesn't exist or the password is wrong. We should always confuse in case an attacker is trying to access the API. Awesome, so our login route is working and let's save this request. So the name, I'll add login and click on save. Perfect. Let's close the tab here. Now back on VS Code, let's create a route here that only authenticated users can access. So that means the client will have to send the access token along with the request. This access token can be sent on the request body, request parameter, but a good practice is to send on the headers of the request. I'll show how to include the access token on the authorization header inside Postman along with the request. In this new route, we return the current authenticated user details that we'll get by the user ID contained inside the access token payload. So app, and this will be a get route, and the name we can add /API, /users, /current. The async word, request and response parameters, arrow function. Now before the client accesses this route, we must ensure the user is authenticated by passing the access token. So we need to add a middleware inside this route, which is a function that will be executed before executing this route. So before the async word here, we can add as many middleware as we want before executing this route. So let's call this middleware function ensure authenticated. Now let's create this function below here. So this will be asynchronous. So async function call ensure authenticated. And since it's a middleware, we'll have access to the request, the response parameters, and also another parameter called next. So whenever we call this next parameter inside the middleware, it will go to the next middleware function. If there isn't a next middleware function, it will execute the route itself. So inside this middleware function, the first thing we need to do is grab the access token from the authorization header sent on the request. So I'll create a new const here, call access token equals to the request parameter dot headers dot authorization. Let's add a validation here, checking if the access token exists. So if exclamation sign access token. So if the access token is not there, then we can send a response to the client. So return response dot status. And here we can also use the 401 unauthorized status code because our user is trying to access a route that requires authentication. In a JSON response with a message saying something like access token not found. So if this response is returned to the client, it won't execute the route here. Now we need to verify if the access token is valid. So I'll add a try block here and a catch block with the error object. So if it falls inside this catch block, that's because the access token is in fact invalid or expired. So we can return a response to the client. So return response dot status, and again we'll use the 401 unauthorized status code dot JSON and a message saying access token invalid or expired. And inside the try block, I'll create a new const here called decoded access token equals to the JWT module dot, and we're going to use the verify function. And this function expects two parameters. The first one is the JSON Web Token, which is the access token. We grab it from the authorization header here. And the second parameter is the secret key we signed the token, which we declare inside the config file. So config dot access token secret. Perfect. So if the token is valid or expired, or if the secret key is wrong, this function will throw an error and fall inside the catch block here. This is why we added the try and catch blocks here. Now, if everything works, the verify function decodes the access token, returning the payload information. So what we need to do is add inside the request object here of the parameter the user details. In our case, the user ID, so we can use inside the route. So I'll call the request parameter dot, and we can add a new property on the request object called user, for example, equals to an object. And inside here we could add more details from the user like name and email, but inside the access token we only added the ID. We could search inside the database on the users table and grab other details, but for our example the user ID is the only information that we need. So ID equals to the decoded access token constant dot the user ID property, which is the one we added here on the login route when we signed the token right here. Back on the middleware function, now we can call the next parameter to go to the next middleware function or to execute the route. Now back on the user's current route, let's add the try and the catch blocks with the error object, and let's copy the error response from up here and paste. And inside the try block, if there aren't any errors in the ensure authenticated middleware function, that means the user is authenticated and we can get the user ID from inside the request parameter here. So I'll create a new const called user, which is equals to await the user's db file dot find one, and inside the object we're gonna search by the underscore ID equals to the request parameter dot user dot ID, just like we added here on the ensure authenticated middleware function. Now let's return the current user details to the client. So return response dot status, and we can use the 200 OK status code dot JSON, and inside an object with the user details like the ID equals to the user constant dot underscore ID. We could grab the user ID from the request object here as well, either way is fine. Then the name equals to user dot name, and the email equals to the user dot email. Once again, we should never return sensitive information here like the password, and since we only have these three fields, that's all we need to return to the client. Now let's save and test this route on Postman. So I'll open a new request here, and this will be a GET request, and the URL is localhost 3000 /API /users /current. And we need to send the access token, return it on the login request. So let me open the login here, and on the body tab I'll just leave the details we have here. Let me just remove the 7 here on the password. Okay, looks correct now, and we can click on send. Perfect, we got a success response. Let me copy the access token here. Remember that this token will expire in 1 hour. Now we need to send this token on the headers of the user's current request. So we can open the headers tab here, and on the key field we'll add a new header called authorization. As you can see, Postman already showed here, and paste the access token on the value. Great, we can click on send, and perfect, we got the 200 OK status code and the user details on the response body. Now, if we uncheck the authorization header here and click on send, okay, we got the 401 unauthorized status code and the message saying access token not found. And if we check the authorization again, and let's hit an invalid token, so I'll add an X here on the end and click on send again. Great, we got the 401 unauthorized status code and the message saying access token invalid or expired. Awesome, let me remove the X here on the end of the access token and click on send again. And perfect, we got the user details again. So our route returning the current authenticated user is working perfectly. So let's save this route. And the name here, we can add current user, click on save, and perfect. Let me close this request here. And let's save the changes to the login request. Okay, now let's create another route here that only a specific user role can access. For example, an admin user. Let me just collapse the routes here. Okay, and let's create a new route below the user current route. So app dot, and this will be a get route. And we'll call this route /API/admin, for example. And we'll call the ensure authenticated middleware here because the user must be authenticated to access this route. And the request and response parameters, arrow function. And inside this route, we're just going to return a simple message to the client just to simulate a route that only admin users can access. So return response.status 200 OK .json and a message saying something like only admins can access this route. Now here on the users DB file, we'll need to add another field to store the role of the user. So for our example, we'll have 3 different roles. The member role, which will be the end users, just like a normal user. Then we'll have the admin that will have full access to the API. And then we'll have the moderator role, which will have access to moderate content. That means some routes only. So let's make some changes here on the register route. So when we're getting the fields from the request body, let's add one more field, which is the role. Okay, but we're not going to verify if this field exists here on the if statement. Instead, if the client doesn't send this field, we're going to assume it's a member user. So here inside the insert function, let's add a new field called role, which is equals to the role here from the request body. And we can add here the double question mark operator that in this case it will insert the role from the request body if it's not null. Otherwise it will insert whatever we added here, so we can put member. Great, now that we have the user role, let's go back to the admin route. So we need to add another middleware function after the ensure authenticated middleware. So let's call this middleware authorize. And inside this middleware function, as a parameter, we can add which rows this route can access. So let's add an array here. And for this route, only users with the admin role can access this route. So first it checks if the user is authenticated, and then it checks if the user is an admin, and then it will execute the route. So let's create this middleware function below here. Let me just collapse here. So function authorize, and for the parameter we expect an array of rows here. So rows equals to an empty array. Now inside we'll return another function containing the request, response, and the next parameters. So return, and this function will be asynchronous, so async function, the request, response, and next parameters. And inside, first we need to grab the user from the database by the ID we have here on the request user. So I'll create a new const here called user equals to await users db file dot find one, and inside the object the underscore ID equals to the request parameter dot user dot ID. We could add the role inside the access token payload here, along with the user ID. So inside the authorized middleware function, we could grab the user role from inside the access token and not make a call to the database. But as a personal choice, I prefer to make a call to the database because it's more secure than passing the role on the access token. But feel free to use the way you prefer. Now I'll add an if statement here, and I'll check if the user doesn't exist on the database, so exclamation user, or if the roles parameter from the authorized function dot includes, and inside the user dot role, and I'll add an exclamation sign here on the beginning. So we can read this as if the user doesn't exist, or if none of the roles we passed on the parameter matches with the user role, then we should return a response to the client saying that the user is not allowed to access this route. So return response dot status, and here we should use the 403 status code, which means forbidden. We should return this status code when the user doesn't have permission to access the request. And also a JSON response with a message saying something like access denied. Now if the user was found and has one of the roles we added on the array parameter, then we can call the next parameter to go to the next middleware function or execute the route. Before we test this new admin route, let's create another route that admins and moderators users can access. So let me copy this admin route here, and let's change the name of this route to /API/moderator instead. And on the authorized middleware function, in addition to the admin role, let's add the moderator role as well. Okay, and for the response message, let's add only admins and moderators can access this route. Great. So now we have a route that only admins can access and another route that only admins and moderators users can access. And since we didn't add the authorized middleware function on the current user route, so that means any authenticated user can access this route. So before we test, let me delete the users.db file so we can test everything from scratch. And back on Postman, let's open the register request, and I'll leave the same details here on the request body, but I'll add the role property here. And for my user, I'll add the admin role. Okay, let's click on send. Great, we got a success response. Now if we check the users.db file, we have a new user here with the role property as admin. Now let's add another user on Postman, and this will be a moderator user. So I'll change the name here to John Doe, and the email initials to JD, and the password we can leave as the same, but the role will change to moderator. Okay, click on send. Great, user registered successfully. Now on the users.db file, let me hide the explorer here. So now we have two users, one admin and one moderator. Let's add a third user, which is going to be a member. So back on Postman, I'll change the name here to Jane Smith, for example. And the email will be js@domain.com. The same password, but I'll remove the role property from here. So the API will assume it's a member user. Okay, click on send. Perfect, we got a success response. Now let's check on the users.db file once again. Here's the new user. So now we have three different users, one admin, one moderator, and one member. Perfect. Back on Postman, I'll open a new request, and we can leave as get, and the URL is localhost 3000 /API/admin. Now let's open the login request, and first I'll log in with the Jane Smith, which is a member user, and the email is js@domain.com. The details here on the request body looks correct. Let's click on send. Perfect, let's copy the access token from the response, and back on the admin request, let's add the access token on the headers. So authorization, and paste inside the value. Now if we click on send, perfect, we got the 403 forbidden status code and the message access denied on the response body. Now let's open a new request here for the moderator route, and it's a GET request, and the URL is localhost 3000 /API/moderator. And let's add the headers, authorization, and paste the access token. Okay, click on send, and perfect. Again, we got the 403 forbidden status code and the message access denied. Now let's log in with a different user. So I'll change here to John Doe JD, which has the moderator role. The password is the same. We can click on send. Great, let me copy the access token and open the admin request first. Replace the authorization header with the John Doe access token. Click on send. And great, we got the 403 forbidden status code because John Doe is a moderator, not an admin. Now let's add the John Doe access token on the moderator request. So let's replace here and click on send. And awesome, we got the 200 OK status code and the message only admins and moderators can access this route because John Doe has the moderator role. Perfect. Now let's log in with my user. So back on the login request, I'll add my initials here on the email. And the password is the same. We can click on send. Great, let me copy the access token. And since my user is an admin, we should be able to access all routes. So let's try the admin request here. Replace the access token and click on send. Awesome, we got the 200 status code OK and the message only admin can access this route. Now let's try on the moderator route. Replace the access token and click on send, and perfect, we got the 200 status code again and the message only admins and moderator can access this route. Awesome, so both routes are working and we just saw how to add authorization to our routes according to the user role. Let's save both these routes. So I'll call this moderator and save. Let me close here. Now the admin request, let's call admin. Click on save. Perfect. Let me just close here. The register request, we don't need to save. And I'll save the login request. Okay, perfect. Now here on the login post route, we sign the access token with an expiration time of 1 hour. But it's a good practice to leave the access token with a lower expiration time, like 1 hour max, and on the login response we should send a refresh token so the client can use to generate a new access token when it expires. The refresh token expiration time should be longer than the access token, depending on the API, a few days, a week, or even a month. So here on the login post route, below the access token creation, let's create the refresh token. So I'll create a new const called refresh token equals to the JWT module dot sign, and as the first parameter we just want to store the user ID here. So inside the object, user ID equals to the user dot underscore ID. Now for the secret key we must create one different from the access token key. So here on the config.js file, let's create a new constant, and this we'll call refresh token secret. And I'll just add a simple key here, so my refresh token secret. Now back on the login route, inside the sign function, I'll call the config.js file dot refresh token secret. And for the third parameter, inside the object, I'll add the subject equals to refresh token, and the expires in, let's put 1 week for example, so 1W. Now we should save this refresh token on the database, so when the client needs to refresh the access token, we should validate if this refresh token exists on the database and if it's still valid. So here on the top, I'll create a new constant simulating another table to store the refresh tokens. So below the users DB file creation, I'll add a const called user refresh tokens equals to the data store dot create, and we'll call this file user refresh tokens dot db. Great. Now back on the login route, let's insert on the new user refresh tokens db file the refresh token we just created. So await user refresh tokens dot insert, and inside the object we'll add the refresh token property, which is equals to the refresh token we created up here. So refresh token, but since the key name is the same as the value name, so we can leave just refresh token here. And let's also store the user ID that received this refresh token. So user ID equals to the user constant dot underscore ID. Great. Now, in addition to the access token, let's also send the refresh token on the response body. So refresh token. Perfect. Now we need to create the route that the client will send the refresh token on the request body. And if this refresh token is valid, we need to send new access and refresh tokens on the response body. So I'll create this route below the login route. So app dot, and this will be a post route, and the name will be /API /auth /refresh -token. The async word, request and response parameters, the arrow function, and inside the try block and the catch block with the error object. And inside the catch block, let's copy the response from one of the routes and paste inside here. Now inside the try block, the first thing we need to do is grab the refresh token the client will send on the request body. So I'll create a new const here, and inside curly braces, we're gonna grab the refresh token from the request.body. Now let's add a validation here, checking if the refresh token exists. So if, and an exclamation sign, the refresh token constant. So if the refresh token is not there, let's return response.status. And here we can use the 401 unauthorized, or the 422 unprocessable entity, or even the 403 forbidden status code. I personally like to use the 401 unauthorized because access and refresh tokens are related to authentication. And the 401 looks better here. And also a JSON response with a message saying refresh token not found. Now, if the refresh token is there, we need to verify if this token is valid and decode the token. I'll create a new const here called decoded refresh token equals, and we're going to use the same process that we did to verify the access token on the ensure authenticated middleware function using the JWT verify method. So JWT module dot verify, and for the first parameter we can pass the refresh token, and for the second parameter the refresh token secret from the config file, so config dot refresh token secret. So if there are any issues here, it will fall on the catch block, but we shouldn't return the 500 status code. Instead, we should check if the error is an instance of the JWT error. So inside the catch block, I'll add an if statement, and we'll check if the error object from the parameter is an instance of the JWT module dot token expired error. So it will throw this error if the token is expired, or error instance of JWT.JSON Web Token error if the token is invalid. So if the error came from the JWT module, that means it happened when the verify function was executed. And then we can return response.status with the 401 unauthorized status code and a JSON response with a message saying refresh token invalid or expired. Okay, Otherwise, it's another error not related to the JWT, so then we can show the 500 status code and the error.message. Now, back inside the try block, we need to find in the database inside the user refresh tokens table if the refresh token sent on the request body exists. So I'll create a new const called user refresh token equals to await the user refresh tokens db file dot find one, and inside the object we're going to search by the refresh token, which is equals to the refresh token that we got it from the request body here. But again, since the key name is the same as the value name, so we can leave just refresh token here. And the user ID, remember when we inserted the refresh token on the user refresh tokens table, we also added the user ID. So here we can get this user ID from the decoded refresh token constant we created up here. So decoded refresh token dot, and inside the refresh token payload we have the user ID. Now let's check if this refresh token exists on the database. So if exclamation sign user refresh token. So if it didn't find this refresh token related to the user ID, so we're going to return the same response from the catch here, saying the refresh token is invalid or expired. So let me copy and paste inside here. Perfect. So in addition to check if the refresh token is valid, we must check if the refresh token was actually stored on the database, if a client actually logged in into the API. So now we can remove the old refresh token from the database by its ID. So here we can add await user refresh tokens dot remove to delete the record, and inside the object the underscore ID equals to user refresh tokens dot underscore ID. Now we just need to call a function from any DB module whenever we update or remove an item from the DB files. AnyDB actually creates a new line saying that the item was updated or removed. To avoid this and actually update or remove the item, we need to call the await user refresh tokens dot compact data file. And this is a function. Great, now we need to generate a new access token and also a new refresh token. Insert this new refresh token on the database and then send on the response body to the client. So here on the login route, we can copy the lines. We're generating the access token, the refresh token, and inserting on the database. Okay, let me paste here. Great. Let's change a few things here. First, let's rename this refresh token constant here to new refresh token, so we don't have a conflict with the constant we already have. So when we sign the access and refresh tokens, we're storing the user ID on the payload. In this case, we're going to get the user ID from inside the decoded refresh token we created here. So decoded refresh token dot user ID. And same here on the new refresh token, so decoded refresh token dot user ID. Okay, now inside the insert function, instead of inserting the refresh token, we need to insert the new refresh token generated, and for the user ID, we can get it from the decoded refresh token dot user ID. Great. Now for the response, we don't need to send the user details here, so we can remove it. And the access token we generated here, and the refresh token is going to be the new refresh token we generated up here. So new refresh token. Perfect, just one small change. So here we're calling the expires in property again, just like on the login route. So let's add the access token and refresh token expires in property inside the config.js file. So below the access token secret, let's create a new constant called access token expires in, and just so we can test, I'll add a very short expiration time here. So let's say 30 seconds, so 30s. And I'll add another constant for the refresh token expires in below the refresh token secret. So refresh token expires in. And just for testing, I'll put 2 minutes, so 2m. Now back on the index.js file, inside the login route, let's replace the access token expires in property to the config file dot access token expires in, and for the refresh token as well, so config dot refresh token expires in. Great. Now same on the refresh token route on the access token. Okay, now on the refresh token. Perfect. Let's test all these changes on Postman. So to make this test, we need to log in again with one of the users we have. So I'll leave the login request open here, and also leave the current user request open so we can test the access token. And let's open a new request for the refresh token route. This is a post request, and the URL is localhost 3000 /API/auth/refresh-token. And let's open the body tab, select the raw option, the JSON type, and inside the body, let's add the refresh token. And we'll paste the refresh token soon over here. Now back on the login request, I'll leave these details on the body so we can click on send. Okay, we got the access token and refresh tokens, and let me copy this access token here, which will expire in 30 seconds. And let me quick open the current user request and paste this token here on the authorization. Click on send, and perfect, we got the success response with the user details. Now let's just wait for this access token to expire. So I'll just keep clicking on send. Okay, not yet. Perfect, we got the 401 status code and the message access token invalid or expired. Now let's copy the refresh token from the login response, which expires in 2 minutes, and paste inside the request body of the new refresh token route. We can click on send, and perfect, we got the 200 status code and the new access and refresh tokens. Let me copy the new access token and paste inside the authorization header here. Click on send, and perfect, we got a success response. And let's wait till this new access token expires. Let's try again. Not yet. Okay. Okay, there it is. So all this will happen on the background. The client will have to intercept all responses from the API, and if the API returned the 401 unauthorized status code, the client will have to call the refresh token endpoint to get a new access token. But just checking for the 401 status code, it's not enough. So the API should send some sort of code informing that the access token is in fact expired, so the client knows what to do next. So back on the index.js file, inside the ensure authenticated middleware function, we need to check if the error inside the catch block is a JWT token expired error. So I'll add an if statement, the error object, instance of the JWT module, dot token expired error. And if it is, we're going to return response dot status, the 401 unauthorized, and a JSON response with a message saying access token expired, and also a code property. And here we'll type something like access token expired. So this is the code that the client will check on the intercept along with the 401 status code. Now let's add an else if statement here, and we'll check if the error instance of JWT dot JSON Web Token error. That means the token is invalid, which is different from expired. If so, let's return response dot status, also 401 unauthorized, and a JSON response with a message saying access token invalid, and also the code property, and here we'll put access token invalid. This code here could also be a number or something else. Just make sure to add this on your API's documentation so the client knows what to check. Let's add another else statement here. So if any other error happen, it's probably not a JWT error. So let's just copy one of the default error response we have here. Okay, and paste on the else statement. Perfect, and we can get rid of this old error message here. Okay, great. Let's just test this again to make sure the response looks correct. So back on Postman, I'll open the login request and click on send. Great, let's copy the access token here. And inside the current user request, let's replace here on the authorization header and click on send. And great, we got the success response. Let's just wait for the 30 seconds till the access token expires. I'll just keep clicking on send. Okay, not yet. Perfect, we got the 401 unauthorized status code and the message saying access token expired and the code saying access token expired as well. So the client knows it have to call the refresh token request. Now here inside the authorization header, let me add an X here on the end of the access token and click on send. Great, now we got the message saying the access token is invalid and the code saying access token invalid as well. So all our error handling is working perfectly. Let's go back to the login request and copy the refresh token. And let's test again the refresh token route. Paste the new refresh token and click on send. And great, we got the new tokens on the response. Now let's say this refresh token gets expired. In that case, the user will have to log in again, calling the login request. So we just learned how to implement the refresh token functionality. Let's save this new refresh token request and the name, I'll add refresh token, click on save, and perfect. Let me just close the tabs we have here and the current user request we don't need to save and the login. Okay, great. Now back on VS Code, as you can see, we have the user refresh tokens DB file here with the refresh tokens we generated and the user ID and also the underscore ID. It has two tokens here because we probably made two requests to the login route without calling the refresh token route. So it saved the refresh token and it saved another when we call the login route. Now let me open the config.js file. And let's change the access token expires in time to the time we would typically use in production. So let's put 30 minutes, for example. And for the refresh token expires in time, let's put 1 week. Great. Of course, this expiration time will depend on the API specifications, but for our project, we can leave it like this. Now, back on the index.js file. So one last thing we need to do here before implementing the two-factor authentication is to add a logout route. So the logout route will delete all user refresh tokens, save it on the database, and also will invalidate the current access token. So we have to store the current access token on a user invalid tokens table because after the user logs out, the client can't use that access token anymore. So let's create the logout route below the refresh token route. So app dot, and this will be a get route, and the name will be /API /auth /logout. And the user must be authenticated so it can log out. So we'll add the ensure authenticated middleware function, the async, request, and response parameters, arrow function, and inside the try block and the catch block with the error object inside. And let's just copy the error response from one of the routes here. And great. Now inside the try block, we'll have to get the current access token from inside the authentication headers. So what we can do is a small change here on the ensure authenticated middleware function. So in addition to store the user details on the request object, we can also store the access token details. So I'll call the request parameter object dot, and let's create the access token property. And this will be equals to an object. So we can store the value of the access token. So we'll create a property here called value equals to the access token that we got it here from the authorization headers. And let's also store the expiration time of the access token, which we can get it from the decoded access token constant here. I'll explain later why we'll use the expiration time of the access token. So here I'll add the exp property, which is equals to the decoded access token dot, and as you can see we have all the details here from the decoded access token like the IIT, but we're going to use the exp, which is the expiration time. And remember, this is in seconds. And great, now back on the logout route. So first let's remove all refresh tokens from the user refresh tokens DB file. So I'll call here await user refresh tokens dot, and we need to make sure that all refresh tokens related to the user are removed. So we can use the remove many method, which will also receive an object with the query filter. So we remove all refresh tokens related to the user ID equals to the request.user.id. And we need to call the compact data file function. So await user refresh tokens dot compact data file function. So we need to store the current access token inside a invalid user tokens table. This is some sort of a blacklist because this access token can't be used anymore. So here on the top, let's create a new DB file simulating this access token blacklist. So I'll create a new constant and we can call this user invalid tokens equals to the data store dot create, and we'll name this file user invalid tokens dot db. Now back on the logout route, let's insert the current access token inside the new user invalid tokens db file. So await user invalid tokens dot insert, and inside an object with the properties we'll store. So we need to store the access token itself. So access token, and we can get it from the request parameter object that we added on the ensure authenticated middleware. So request dot access token object dot, and we stored it inside the value property. Now let's store the user ID as well, which we can get it from the request.user.id. And last, let's store the expiration time of the access token, because this user invalid tokens DB file might get big, so we should delete all access tokens that are already expired. So I'll add the expiration time, and we can get it from the request.access token dot the exp property that we added along with the access token value. So what we can do is run something like a cron job every day to delete the expired access tokens by checking the expiration time, which is lower than the current date time. If you want to learn more about cron jobs, there's a video here on the channel explaining how to create cron jobs using Node.js with lots of examples. I'll leave the video link on the description below. Awesome, now all we need to do is return a response to the client. So return response.status, and here we could send a 200 OK status code, but since we don't need to send anything on the response body, we can send instead the 204, which means no content. The 204 is also a success response, but the server doesn't have anything to return to the client. And then the .send function. Now, before we test this logout route, we need to check on the ensure authenticated middleware function if the access token exists on the user invalid tokens DB file. So if it is, that means the user is already logged out and the access token is no longer valid. So after checking if the access token is on the authorization headers, I'll add another if statement here and await user invalid tokens dot find one. And inside the object, the access token field, equals to the access token from the authorization header here. And since the key name is the same as the value name, so we can leave just access token. If it does exist, then we need to return the same response we are returning here on the catch block, where the access token is invalid with the code as well. So let me copy and paste inside here. Great. Now let's test all these changes on Postman. So I'll open the login request here and I'll leave my user credentials and we can click on send. Perfect, we got the success response and the tokens. Now let me open the current user request and let me copy the access token from the login response here. And back on the current user request, let's replace the authorization header with the access token we just copied. And click on send. And perfect, we got the 200 OK status code and the user details on the response. Now let's open a new request tab here for the logout route. And the method we can leave as get. And the URL is localhost 3000 /API/auth/logout. And on the headers tab, let's add the authorization and paste the access token here. Great, let's click on send. And we got the 204 no content status code and nothing on the response body. Now let's open the current user request tab again. And here we have the access token that is stored on the blacklist, which is the user invalid tokens DB file. So when we click on send, we got the 401 unauthorized status code and the error message and the code as well informing that the access token is invalid. That's because the user is already logged out from the API. Now if we check here on VS Code, we have a new user invalid tokens DB file. And here we have the access token we just added. And if we scroll here to the end, we also have the user ID and the expiration time of the access token, which is in seconds. And inside the user refresh tokens DB file, all refresh tokens related to my user was deleted from here. So the user is fully logged out from our API. There might be a situation where the user is logged on different devices. Let's say a browser and a mobile app. And what we did here will log out the user in all devices because we are deleting all refresh tokens. But what we can do is change this to a post request, for example, and the client can send the refresh token of one of the devices the user is logged. So we can expect here the refresh token, for example, coming from the request body. In that case, instead of deleting all refresh tokens from the user, let me comment here. Okay, we can instead delete only the refresh token sent on the request body. So for example, we can call the remove method and add a filter here to delete the refresh token equals to the refresh token sent on the request body. So here on the user refresh tokens DB, there might be more refresh tokens stored on this file for the current user, but from different devices. But for our example, let me add everything back here. So this will log out the user completely from our API. But depending on your API requirements, you can implement this functionality and maintain the user logged on other devices as well. Okay? Perfect. Let's just save this logout request here on Postman by clicking on save. And I'll call this logout. Click on save again. Great. Let me just close these tabs here. And we don't need to save the current user request and the login. Okay. So till now we implemented everything that a basic authentication and authorization should have on an API. The registration, login, refresh token, and the logout endpoints. And the middleware functions we use to ensure the user is authenticated and also authorized to use certain routes depending on the user role. Now it's time to implement the two-factor authentication, and we're going to use an authenticator app for this instead of sending an email or SMS with a PIN code. So before we start, let's install the modules we'll be using to implement the two-factor authentication. So I'll open the terminal here on the top, and stop the server by pressing Ctrl C. And let me clear and type npm install. And we'll need a module to generate a QR code so the Authenticator app can read from our API. And for this project, we're going to use the QR code module. We also need a module to generate a secret key that we'll add inside the QR code, and we'll also validate the PIN codes that the Authenticator app will generate. So for this, we'll use a module called OTP-lib. And last, we need a module to store data on the cache. Usually I'll recommend Redis, which is really robust, but we'll need to install Redis on our machine. So instead, I'll install Node.js, which is really easy to use and is the same idea of Redis, but instead the data will be stored on memory. We can hit enter. And perfect, modules installed, and we can check here inside the package.json file. Here's the new modules. Now we're going to assume that the user is already authenticated and wants to enable two-factor authentication for an extra step to authenticate it in addition to calling the login endpoint. So we'll need to create a new route that will generate the QR code and send on the response body so the Authenticator app can read this QR code and create a relation with the logged user on our API. So let me close the terminal for now. And first, let's create the route that will generate the QR code. Let me just collapse the route we already have. Okay, so below the refresh token route, I'll call app dot, and this will be a get route. And the name of this route will be /API /auth /2FA, which stands for two-factor authentication /generate. And the client must be authenticated to access this route. So ensure authenticated, middleware, and the async, request and response parameters, arrow function, the try and the catch blocks here, the error object, and we're already familiar with this route creation. So let's copy an error response here and paste. And great. Let me just hide the explorer here. Now inside the try block, we'll need to get the details of the Authenticator user, generate the secret key, and add all this information on the QR code so the Authenticator app reads and understands that we're creating a relation between our API, the user, and the Authenticator app. So here on the top, we'll start by getting the user details. So const user equals to await the user's db file dot find one, and we're going to search by the underscore ID, which is equals to the request parameter dot user dot ID. And next we'll generate a secret key using the OTP-lib we just installed. So let's import the OTP-lib on the top below the JWT module import. So const, and I'll add curly braces here, equals to require OTP-lib. And we're going to extract the Authenticator class from inside the OTP-lib. And let's also import the QR code module. So const QR code equals to require QR code. Great. Now back on the 2FA generate route, I'll create a new const called secret, which is equals to the Authenticator class we just imported, dot generate secret method. And next we need to generate a URI using the Authenticator class and add into the QR code. So I'll create a new const called URI equals to Authenticator dot key URI. And this expects three parameters. The first parameter is the account name, which is the user. So here we can add the user email, for example. So user.email. And the second parameter is the issuer. It can be a company name or some other name that when the Authenticator app reads the QR code, it will show for who or what the Authenticator app is generating the PIN codes. So here I'll add manfra.io, for example. And the last parameter is the secret. So we can put the secret we just generated up here. Now, every time the client authenticates, it has to send the secret as well. So we need to save the secret on the user table. Each user will have its own secret key. So back here on the register route, when we are inserting the user on the database, let's add two new fields, which will be if the two-factor authentication is enabled for this user. So inside single quotes, we'll add the 2FA enable field, and by default this will be false. And next, the 2FA secret, and by default we'll put null. Awesome. Now back on the 2FA generate route, let me just hide the refresh token route here, and let's update the current user to FA secret with the secret we generate above here. So await users dot update, and the first parameter is the query search for which user we want to update. So inside an object, we want to find by the underscore ID, which is equals to the request dot user dot ID. And the second parameter is which fields we want to update. So inside an object, we need to add a $sign and then set, and this is equals to another object, and we want to update the 2FA secret, which is equals to secret. And then we need to call the await users dot compact data file function. Now let's generate the QR code. So I'll create a new const called QR code equals to await the QR code module dot, and we're going to use the toBuffer function. And the first parameter here is the data we want to add to this QR code. In this case, we want to send the URI we created here using the authenticator. And the second parameter, we can configure some options here. So I'll add an object, and we can configure the type property, and we can put image/png. And we can also add a margin. The default is 4, so we'll change it to 1. And now we need to send this QR code on the response body. We could send the base 64 of the QR code image, and then the client will display the QR code on the browser or mobile app. But we're going to send the actual QR code image on the body response, which the client can use as well. To do so, we'll call the response parameter dot set header, and we're going to set the content dash disposition property to attachment, and I'll add a semicolon here. File name equals to, and we can call this image QR code .png. And now let's return to the client. So return response.status, and we can use the 200 OK dot type image/png dot send, and inside the QR code we generated. Perfect. Before we test this, let me delete all DB files that we have so we can start the entire flow from scratch. Perfect. Now let me open the terminal and run the server. So npm start. Okay, now back on Postman. I'll open a new request tab here, and we can leave as git, and the URL is localhost 3000/API/auth/2FA/generate. Now let's open the register request. I'll leave these details here on the request body, and I'll just click on send. Great. Now let's go back to VS Code. If we check on the users DB file, you can see that now we have the 2FA enable property as false and the 2FA secret as null. Back on Postman, let's authenticate this new user. So I'll open the login request, and we can leave the details as it is. Click on send, and great. Let's copy the access token. And here on the 2FA generate request, let's open the headers tab and add the authorization and paste the access token here. We can click on send. And great, we got the 200 OK status code and we got the QR code we just generated on the response body. Now we need an authenticator app to read this code so we can see the result. So we have some options here to test. You can install an authenticator app on your personal smartphone like Google Authenticator, Microsoft Authenticator, Twilio Authy, or if you're using Chrome, there are some extensions that simulates an authenticator app as well. But since I'm using Mac, there is an authenticator app available and we can download and install from the App Store. So let me bring this authenticator here. And as you can see, there are no other accounts added here. And we can click on the plus sign here on the bottom to add a new account. This will open a camera and we can scan our QR code here. So let me drag here on top. And that's it. It shows that we can connect to a service called manfra.io using my personal account with the email bm@domain.com. And this is the secret key that was generated. And if we check here on the users.db file, it's the same secret key that we have on the 2FA secret field. So let me bring the authenticator app here so we can compare. So as you can see, it's the same secret key. So we are creating a relation between the authenticator app and the user. Okay, so we can click on save. And perfect, the authenticator app is configured, and as you can see, it's generating a PIN code every 30 seconds and it's related to my user account and our API. Now we need to create another route to validate if one of these generated PIN codes are working, and then we can enable the user to use two-factor authentication on our API. So back in the index.js file, let's create this new route below the 2FA generate route. So app dot, and this will be a post route because the client will send data, and we'll call this route /API /auth/2FA/validate. The ensure authenticated middleware function, async, the request and response parameters, arrow function, the try, and the catch blocks. Error object. And let's copy our default error response here. Okay, now inside the try block, so the client will send the PIN code valid at the moment that the authenticator app is generating. And sorry, I forgot to mention that this PIN code is called TOTP, which stands for time-based one-time password. So here inside the try block, we need to get the TOTP from the request body. So const curly braces TOTP equals to request.body. Next, we'll just add a validation here to check if the TOTP exists. So if exclamation TOTP. So if it's not there, we're gonna return response.status. And here we can use the 422 unprocessable entity.json with a message saying TOTP is required. Next, we need to get the 2FA secret from the current user. So I'll create a new const here called user equals to await users dot find one. And inside the object underscore ID equals to request dot user dot ID. Now we need to verify if the user secret matches with the current TOTP the authenticator app is generating. So I'll create a new const called verified equals to the authenticator module dot check method, and the first parameter is the token, that means the TOTP that the client is sending, so TOTP. And the second parameter is the user 2FA secret, so user. And we can't use the .2FA secret directly here because it starts with a number. So instead we can put inside an array and the 2FA secret inside quotes. Of course you can change this field here to whatever you prefer. So the check function will return true as long as the TOTP is still within the acceptable time window. So let's validate the verified constant we created. So if exclamation sign the verified. So if it's not valid anymore, we're gonna return response.status. And here we can use the 400 bad request status code, which indicates that the server cannot process the request due to something the client is sending that is wrong. This is similar to the 422 unprocessable entity, which we could use here as well. And then a JSON response with a message saying TOTP is not correct or expired. If the TOTP is valid, that means everything is working and we can enable two-factor authentication for the user. So let's update the current user to FA enable property. So await users dot update, and we're gonna find the underscore ID equals to request dot user dot ID, and then the $ set equals to an object with the 2FA enable field equals to true. And then we need to call the await users dot compact data file function. And last, we need to return a response to the client. So return response dot status 200 OK dot JSON with a message saying something like TOTP validated successfully. Awesome. So before we test, we can check on the users DB file that the 2FA enable is false. Okay, let's save the index.js file and let's test this new route back on Postman. Let's open a new request tab here, and the method will change it to post, and the URL is localhost 3000 /API /auth /2FA /validate. And let's open the headers tab so we can add the access token. And let me open the login request and copy the access token. Now back on the 2FA validate route, let's add the authorization and paste the access token here. Okay, now let's open the body tab, select the raw option. We can leave the JSON type here. And we need to send on the body the TOTP, which is equals to, let me open the Authenticator app here. And we can copy the code by clicking on top of it. And let's wait for this code to expire. We can see the time left here. Okay, now let's try to use this expired code here on the body. Click on send. And great, we got the 400 bad request status code and the message saying TOTP is not correct or expired. Now let's copy another code from the Authenticator app. So let me open here and let's copy. Okay, and paste this code here, which is still valid. Click on send. And perfect, we got the 200 OK status code and the message saying TOTP validated successfully. And if we check on the users.db file, the 2FA enable property is true. That means the user can use the two-factor authentication. Awesome. We need to do a few changes here on the login route, because if the user doesn't have two-factor authentication enabled, if the 2FA enable property is false, the client will just receive what we have so far, the access and refresh tokens on the response, and that means the user is already authenticated. Now, if the user have two-factor authentication enabled, so we need to generate a temporary token, save this token in the server's cache for a short period of time, just a few minutes, and send this temporary token on the response instead of sending the access and refresh tokens. So then the client will need to call a new route that we're going to create, passing this temporary token and the TOTP the Authenticator app is generating. And if the TOTP is valid and the temporary token is still valid as well, then we're going to send the access token and refresh tokens on the response, and the user will be authenticated. So let's start by making some changes here on the login route. So after we check if the user password is valid, we're going to check if the user has two-factor authentication enabled. So I'll add an if statement here and call the user. We declared here on the top an array, and inside the 2FA enable in quotes. So if it is enabled, let's generate the temporary token, and we can use whatever we want to generate this token, even a JSON Web Token, for example. But for our project, we'll generate a simple UUID code, and we can use a built-in module from Node called crypto. So let's import crypto here on the top. So const crypto equals to require crypto. Now back on the login route, I'll create a new const called temp token, which is equals to the crypto module dot random UUID function. This will generate a random code using the version 4 UUID. Now we need to store this token on the cache. So for that, we'll use the node cache module. So let's import here on the top. So const node cache equals to require node cache. And we need to initialize node cache. So below the express JSON configuration, let's create a new const, and we'll call cache equals to new node cache class. And node cache stores data as a key value pair. So the key will be the temporary token we generated here on the top, and the value will be the user ID, because we'll use the user ID to authenticate the user. So I'll call the cache we just initialize dot set, and this accepts 3 parameters. The first parameter is the key. So personally, I like to store the key with a name prefix, something like temp underscore token column and the temp token itself. So if we need to check what we have stored on the server's cache, by reading the prefix, we know what that data is. So we'll add this name prefix here on the config.js file. So I'll create a new constant called cache temporary token prefix. And this will be temp underscore token. And I'll add a column on the end. So back on the index.js file, I'll call the config.cache temporary token prefix constant, and I'll concatenate with the temp token we just created. And the second parameter will be the value, which will store the user ID. So user dot underscore ID. And we can also include a third parameter, which is called the TTL, which stands for time to live, and it's the period that this temp token will be stored on the cache. This is in seconds, and we'll store for 180 seconds, which is 3 minutes. So let's save this TTL on the config file as well. So I'll create a new constant below the cache temporary token prefix, and we'll call this cache temporary token expires in seconds. And this is equals to 3 minutes. That means 180 seconds. Back on the index.js file. So I'll add here on the third parameter the config.cache temporary token expires in seconds. Perfect. Now all is left to do is return a response to the client with this temporary token. So return response.status 200 OK .json with the temp token, and we can also send the time that this will expire so the client can inform the user. So expires in seconds equals to the config.cache temporary token expires in seconds. Now we need to add an else statement here. Now inside, let's select the entire code we have left here, generating the access token, cut, and paste here. Okay, so if the client or user has the 2FA enabled, we're generating the temporary token and sending on the response. So it's not fully authenticated yet. Otherwise, if the client or user doesn't have the 2FA enabled, so that means it's already authenticated and we can send the tokens on the response. Let's just make sure the changes we did on the login route is working. So back on Postman, I'll open the login request and I'll just leave my user here because it has the 2FA enable property as true. So if we click on send, Perfect, we got the OK status code and the temp token and also the expired in seconds of the temp token. Now we need to create another route so the client can pass this temp token and the TOTP that the Authenticator app is generating. If both this information is valid, then we can authenticate the user and send the access and refresh tokens. But before we create this route, let's just register a new user that by default the 2FA enable field is false. So we can check the login request if instead of sending the temp token, it has to send the access and refresh tokens. So let me open the register request here and I'll change the name to John Doe again and the email to jd@domain.com and the password I'll leave as the same. And we can click on send and perfect. Now let's go back to the login request. And I'll change the credentials here to the new user, the email, and the password is the same. We can click on send, and there it is. We got the access and refresh tokens because this user doesn't have the 2FA enable. Great, so the login request is complete. Now back on VS Code, let's create the new route that will be the second factor authentication that the client have to call after the login request. So below the login route here, I'll call app dot, and this will be a post request. And we'll call this request /API /auth /login /2FA. The async, request and response parameters, the arrow function, the try and catch blocks with the error object. And let's just copy a default error response here. Okay, great. And inside the try block, the client will have to send the temp token and the TOTP from the Authenticator app. So I'll create a new const and curly braces with the temp token and the TOTP equals to request.body. And let's just add a validation here to check if these fields are in the request body. So if exclamation sign temp token or exclamation sign TOTP. So if one of these fields are not on the request body, and then we can return response.status and the 422 unprocessable entity code .json with a message saying please fill in all fields, the temp token and the TOTP. Now if these fields are available, first we need to get the user ID that is saved on the cache where the key is the temporary token. So I'll create a new const called user ID equals to the cache dot get, and as a parameter it expects the key and return the value. So I'll call the config dot cache temporary token prefix concatenate with the temp token, and this will return the value which is the user ID. Let's also add a validation here to check if the temp token still exists on the cache. So if exclamation sign user ID. If it's not on the server's cache, then we can return response.status. And here we can use the 401 unauthorized because this route is related to authenticating the user. Then a JSON response with a message saying something like the provided temporary token is incorrect or expired. Now if the temp token is still there, we need to get the user to FA secret to validate if the TOTP is valid. The same validation we added on the 2FA validate route. So first let's get the user details. So const user equals to await users dot find one, and inside the underscore ID equals to the user ID. We got it from the cache. Now we need to check if the TOTP is valid using the user2FA secret. So I'll create a new const called verified equals to the authenticator module dot check, and the first parameter is the TOTP the client is sending. So TOTP, and the second parameter is the user secret that we can get it from the user we have up here. So user array, and inside single quotes the 2FA secret. Now let's validate the verified constant. So if exclamation sign verified. So if this is false, that means the TOTP is incorrect or expired. So return response.status, and we'll also use the 401 unauthorized .json with a message saying the provided TOTP is incorrect or expired. Now, if everything is valid, the temp token and the TOTP, so we need to generate the access and refresh tokens and return it to the client. So we can copy the same code we have here on the login route, the return statement till the access token generation. Okay, and paste inside the 2FA login route. Let me just check if everything here is correct. The access token, okay, the refresh token, inserted on the refresh token table, okay, and the response with the user details and both tokens. Awesome. So now let's test this complete two-factor authentication flow back on Postman. I'll open a new request tab here, and this is a post request, and the URL is localhost 3000 /API /auth /login /2FA. Open the body tab and select the raw option and the type as JSON. And on the body, I'll add the temp token, which we'll paste here soon, and also the TOTP, which we'll copy soon from the Authenticator app. Now I'll open the login request, and I'll change the email here to myuser@domain.com, which the 2FA enable field is true and the password is the same. We can click on send. Great, let's copy the temp token, which is valid for 3 minutes. And back on the 2FA login request, let's paste the temporary token here. And let me bring the Authenticator app. Okay, let's copy the TOTP and paste on the body here. Okay, click on send. And perfect, we got 200 OK status code and the access and refresh tokens on the response body. Perfect. Let's just do another test here to validate the temp token, for example. So here on the config.js file, the cache temporary token expires in seconds constant. Let's change this to 10 seconds, for example. Okay, now back on Postman. I'll open the login request again. Click on send. Great, let's copy the temp token. And on the 2FA login request, I'll paste the temp token here. And let's copy the TOTP from the Authenticator app. Let's wait till expired. Okay, copy and paste inside the body. And by this time, the temp token is probably already deleted from the cache because we added the expiration time to only 10 seconds. And let's click on send. And perfect, we got the 401 unauthorized status code and the message saying the provided temporary token is incorrect or expired. Awesome. Now back on the config.js file, let's add the 3 minutes back, so 180 seconds. And let's try again, but this time we'll wait for the TOTP to expire. So I'll open the login request again, click on send. Okay, copy the temp token. And on the 2FA login request, I'll replace the temp token here. And let's open the Authenticator app. Copy the current TOTP, which is almost expired, and let's wait for it to expire. Okay, and paste inside the body. Click on send. And perfect, we got the 401 unauthorized status code and the message the provide TOTP is incorrect or expired. So the validations are working as well, and we completed the two-factor authentication flow. Let's just save all the new requests we created here. So the 2FA generate request, and we'll call this generate QR code. Save. Now the 2FA validate request, and we can call this validate / enable 2FA. Save. And last, the 2FA login request. And we can call login -2FA. Great. Let me just close all tabs we have open here. Okay, so now we have all requests saved. As you can see, this is a very laborious feature to implement, but when it comes to security, every effort is worth it. So we saw in this video how to implement REST API, authentication, and authorization. We learned many features like password hashing, JSON Web Tokens, refresh tokens, two-factor authentication, store data on cache, and how to put everything together. If you want to learn more about REST API, there's a playlist here on the channel with tutorials explaining the basic concepts of REST API with MongoDB, and also with Postgres. I'll leave the link of the playlist on the description below, and also the GitHub repo link for this project. Hope this video was helpful to you, and if it was, please click on the like button and subscribe to the channel so we can continue making more videos like this. Thank you so much for watching, and see you on the next video.